Once again, welcome. My name is Mwiza Chirwa. I'll continue in this video. I will continue from where I stopped from the previous one. We are still working on the same topic, chemical bonding. So the success criteria that we're going to achieve after this lesson there are two. You should be able to describe covalent bond and as well as metallic bond. So by the end of the lesson, you should be able to describe covalent bond and metallic bond. Remember, I said we have three types of bonds. We have three types of chemical bonding. We have ionic, covalent, and metallic. So in this video, we are going to look at the remaining two. So covalent bonding. What is a covalent bond? It is a type of chemical bond in which elements involved share electrons for them to reach electron configuration of noble gases. So the definition now it is giving us another food for thought. We need to look at how do atoms attain stability. Now from this definition, we can conclude that atoms attain stability by losing electrons, gaining electrons, as well as sharing electrons. The covalent bond, the elements which are involved, they have similar or the same attraction force towards the electrons. This type of bond occurs in nonmetal only. So one thing that we can look into this one, we are saying that it occurs in nonmetal elements only. That's why they are sharing electrons. Why is it like that? It's because nonmetal elements have similar or same attraction force towards the electrons. All of them, they have the capacity to gain the electrons. They have strong nuclear charge. Therefore, we expect them not to lose the electrons, but to share the electrons. From there, how is covalent bond formed? When nonmetal elements combine, specifically covalent bonding is for combination of nonmetal only. So when they combine, they share electrons for them to be stable, because nonmetal elements have similar nuclear charge. Hence, they do not lose or gain electrons, but they share the electrons for them to be stable. The shared electrons are the valence electrons of each atom of the element involved. So the valence electrons, they contribute some valence electrons, and those valence electrons are shared. The atoms forms an overlap. When we're looking at an overlap, we're looking at an intersection. After they donate the shared pair shared of electrons, it can be pair or it can be a single electron, each atom can donate. If they donate the shared electrons, each nuclear charge attracts to the shared electrons and form an overlap. So that overlap, it means this one is attracting to the shared electrons, the other one will also attract to the shared electrons. Their nuclear charge are going to attract the electrons as their own. So if each nuclear charge attracts the electrons as its own, it forms a force. That force is known as a covalent bond. That's why it's known as covalent bond. So in this type of bond, there are no ions formed. So we have some kinds of covalent bond, how the covalent bond can be formed. We have a single, when we're saying single covalent bond, simply mean that in this type of covalent bond, each atom which is involved, each nonmetal element which is involved, share only a single electron for it to be shared amongst them. So for example, in single covalent bond, which is formed by sharing of one electron pair between two atoms, in which each atom contributes one electron. So when we're talking about a pair it means two, but amongst those two electrons, each electron is contributed by each atom which is involved. It is represented by putting short lines. Short lines, we are referring to this one, short lines, bonding lines between two atoms. Consider the formation of the molecule of hydrogen. We have hydrogen here. So hydrogen, this one has an electron in the outermost shell. This one also have a single electron in the outermost shell. But for them to be stable, they are supposed to have 2 electrons. That's why this one shared 1, this one also shares 1. So when we're talking about overlap, we're looking at this one, overlapped, all and intersect. This one is formed because the nuclear charge attracts these shared electrons to itself. So when this one attracts the shared electron to itself, this one also attracts the shared electron to itself, they all form a bond here, like this one. This bond is known as covalent bond. We can continue looking at how the hydrogen formed. So here we have a single hydrogen atom, here a single hydrogen atom, they are joined together here. So we're saying hydrogen atom has 1 electron, its valence electron, and a single energy level. Hence, it only needs to gain 1 electron for it to be stable. Why it needs to gain 1 electron for it to be stable? Because it has a single energy level, which is only can only get maximum of 2 electrons. That's why it needs to gain 1 electron. So there another example that we can look about single covalent bond. It's a formation of a chlorine molecule. We have a chlorine here which has 7 electrons in the outermost shell. For it to be stable, we're remaining with 1. Same applies to this one. So these chlorine, they do not share all of their valence electrons. Since they only need 1, each atom is going to share 1. So the nucleus is going to attract these 2 electrons as its own electrons. By doing so, both of them, as they attract, they form a bond. Chlorine atom has 7 electrons in the outermost shell. For the chlorine atom to attain stable octet electron configuration, this term, octet electron configuration, we are just referring to as electron configuration of noble gases. Noble gases are group 8 elements. So we're saying for chlorine to attain electron configuration of group 8 elements, it needs 1 electron. A chlorine atom can share its 1 valence electron with another chlorine atom. In doing so, a pair means 2. Pair of electrons is shared between the 2 chlorine atoms, but each chlorine atom has contributed 1 electron in that pair. The nuclear charge of each chlorine atom attracts the electrons and form a bond. This bond is known as covalent bond. Double covalent bond. Remember we talked about single, now we are going to double. What is double? Double means 2. It is a bond that is formed by sharing 2 electrons pair. When they're talking about 2 electron pair, it means now each atom involved contribute 2 electrons. So if each contribute 2 electrons, a pair comprises of 2. It means we're going to have 2 pairs. It is formed by putting 2 short lines. The lines, these are these ones, the bonding line. The line represents 2 electrons. The other one from this, the other one from that. That's why we're saying here it is formed by putting 2 short lines between 2 atoms. For example, let us consider the formation of oxygen molecule. Remember, oxygen is coming from group number 6. Oxygen has 6 electrons in the outermost shell. As we can say, for example, this oxygen atom, the blue electrons here, we can count, there are 6, including these 2 which have been shared. This one, the red ones, there are 6, including these 2 shared. So for it to be stable, it's supposed to have 8 electrons in this shell. So what happens? Each shares 2 electrons. So when this one shares 2 electrons, the remaining ones are 4. While this one, when shares 2 electrons, the remaining ones are 4. So if we are to count all of the electrons here, it means this atom has 8. Since the nuclear charge attracts all the shared electrons here, same applies to this one, is going to have 8 because the nuclear charge is going to attract this one. As this one attracts to the electrons, shared electrons, as this atom attracts the shared electrons, an overlap which is going to be created here, and force of attraction between these 2 is going to be formed, known as covalent bond. Now we can go into details how formation of oxygen molecule occurs. An atom of oxygen has 6 electrons on its outermost shell. For an oxygen atom to attain stable octet electron configuration, it needs 2 more electrons. An oxygen atom can share its 2 valence electrons with another oxygen atom. As already said, that each contribute 2. Why is it contributing 2? For it to be stable, it's supposed to gain 2 extra, so the other one contribute 2 and make it 4. In doing so, 2 pair of electrons are shared between the 2 oxygen atoms. Pair means 2 electrons. So it means if we're saying 2 pairs of electrons, it means we have 4 electrons. 2 have been contributed by 1 oxygen atom, and 2 will also be contributed by another oxygen atom. Therefore, a double covalent bond is formed. The term double, I repeat, we are referring to each atom involved contributing 2 electrons. So if each contribute 2 electrons, the electrons they are going to be 4. In 4, we are going to have 2 pairs. We can represent the oxygen molecule formed using either a dot and cross diagram, which we are going to show in the next slide, as well as we can also use a bonding line. Bonding lines are like these ones. One line represents 2 electrons. So if there are 2 lines, it means there are 4 electrons. So as we can see here, we can use dot and cross. A dot is this one, a cross is this one. These ones represent electrons in the outermost energy level. While a bonding lines, there are these ones. I've already said this one line represents 2 electrons. One which is donated by this oxygen, the other one donated by oxygen. Same applies here. So it means this oxygen donates 2 electrons. This one also donates 2 electrons. So the other one is triple covalent bond. What is triple covalent bond? Now we have an idea. In this bond, it means each atom which is involved shares 3 electrons. That's why we're saying it's a bond that is formed by sharing of 3 electrons pair between 2 atoms, in which each atom contributes 3 electrons. So when we're talking about we have 3 pairs, a pair constitutes of 2 things. So if we're going to have 3 pairs, it means we have 6 electrons. Each atom involved contribute 3. So if each atom contribute 3, the other one contribute 3. If you combine, you're going to have 6 electrons. But in terms of pairs, we have 3 electron pair. We can have an example of nitrogen molecule. It is represented like this one. Nitrogen is coming from group number 5. It means in the outermost energy level, it has 5 electrons. For it to be stable, it's supposed to gain 3 electrons. So it contributes all the 3 electrons here. For example, here we're using the cross. It has contributed this one, and this one. While this atom of nitrogen is using the dots, it has contributed 3 as well. So if we count here, we're going to have 6 electrons, in which this nucleus of this nitrogen attract as its own electrons, making it stable with the remaining 2 electrons which are here. So if we are to count the total number of electrons in the outermost shell, they are going to be 8, making this atom to be stable. But since it's attracting the shared electrons, this one also attracts the shared electrons. So if this atom and this one attract the shared electrons, they form a bond. That bond is known as covalent bond. Formation of nitrogen. An atom of nitrogen has 5 electrons in the outermost shell. For nitrogen atom to attain stable octet, we have already said that octet means electron configuration of noble gases supposed to gain more 3 electrons. So nitrogen atom can share its 3 valence electrons with another nitrogen atom. In doing so, 3 pairs of electrons are shared between the 2 nitrogen atoms, and a triple covalent bond is formed. We can represent the nitrogen molecule formed using either the dot and cross diagram, or we can use triple lines. I've said these lines are also known as bonding lines, which means a single line represents 2 electrons. So if there are 3, it means we have 6 electrons. So this is the diagram showing us how a triple nitrogen molecule is formed, or triple covalent bond of nitrogen molecule formed. This nitrogen contributing 3 electrons here, this one contributing 3 electrons here, forming 3 pairs of electron, and we can also use these lines. Formation of water molecule is the same, covalent bonding. An atom of oxygen has 6 electrons on the outermost shell, while an oxygen atom attains stable octet electron configuration, configuration of noble gases or group 8 elements, it needs to gain more 2 electrons. But if you can check now, hydrogen has 1 electron. That's why here we have 2. For oxygen to be stable, it needs 2 electrons. So it needs 2 hydrogen to share its electrons. That's why here we have 2 here. Had it been that oxygen only needed to gain 1 electron, I think this one would have not been there. Remember, on the formation of chemical formula, we swap the charges. The reason why we swap these charges is to balance number of atoms which are going to be found in a bond. So if we don't swap, it means the number of atoms cannot balance, and it will be very difficult for us to come up with the bond. So for hydrogen atom to attain stable duplet electron configuration, duplet means 2, configuration simply means electron configuration of noble gases, specific helium, it needs 1 electron. An oxygen atom can share its 2 valence electrons with 2 hydrogen atoms. That's why here we have 2. Remember, I've said that this one is coming from formation of chemical formulas, where we are looking at the valences and we are swapping. So this 2, it means it came from oxygen going there in order to balance number of hydrogen atom in this bond. An oxygen atom can share 2 valence electrons to 2 hydrogen atoms. In doing so, a pair of electrons is shared between the oxygen atom and each of the 2 hydrogen atoms. 2 single OH covalent bonds are formed. For example, this is oxygen. It will share this electron with this one and this one with this one. Doing so, it is going to form a bond like this. In this bond, each atom involved now has reached electron configuration of noble gases. Because if you check on this hydrogen, it has 2 electrons now. It means it is stable. Same applies to this one. Same applies to oxygen. Now we have 8 electrons. Diagram showing this one can also be illustrated in this one using a dot and cross diagram, just illustrating how water molecules form. We can also use a bonding line. Remember, bonding line, we say it represents 2 electrons, so we can have this one and this one representing water. Another one which you can learn as well is from carbon dioxide. We said carbon dioxide, first of all, the valences for carbon was 4, oxygen was 2, and to do that, since their valences had a common factor 2, we had to divide by 2 to come up with CO2. It means in this bond we are going to have 2 oxygen atoms with 1 carbon atom. It means each oxygen atom is going to share 2 electrons, and carbon is going to share 2 electrons to 1 oxygen and 2 electrons to another one. So in a molecule of carbon dioxide, it's made up of 1 carbon atom and 2 oxygen atoms. An atom of oxygen has 6 electrons in the outermost shell. For oxygen atom to attain stable octet electronic configuration, it needs 2 more electrons. An atom of carbon has 4 electrons for it to in the outermost shell. For carbon atom to attain a stable octet electron configuration of noble gases, it needs to gain more 4 electrons. Carbon atom can share its 4 electrons with the 2 oxygen atoms. So it means each 2 electrons with another oxygen and 2 with the other one. In doing so, 2 pairs of electrons are shared between the carbon atom and each of the oxygen atom. Double CO is going to be formed like this one. Covalent bond is formed. So let us look in into the diagram properly, we have carbon here with four electrons, and the 2 electrons is going to be shared with this oxygen, as you can see here, and the 2 electrons shared by this one. By doing so, it means this carbon is going to be stable. We have now the nuclear charge will attract to the shared 8 electrons here, and the oxygens are also going to be stable. This is how carbon dioxide is formed. From there, we'll look at the last type of chemical bond, that is metallic bond. Usually this one occurs only in metal elements only. You cannot find metallic bond in non-metal elements. This bond increases the strength and the rigidity of metals. So the metals are very strong. It's because of this type of bond, which exists only in metal elements only. So how is metallic bond formed? So we have a structure of a metal. So in that structure of a metal, you are going to see, since it's in solid form, it have fixed atoms. So these are the positive ones are fixed atoms. The negative ones here, they are just electrons which are moving through this structure of a metal. So let us look at how metallic bond is formed. So the fixed metal atoms that we are seeing from the previous slide, and the metallic structure release its valence electron. Since a metal is a metal, it means the nuclear charge is not strong. It's able to release its valence electrons and become positively charged. So when it releases its valence electrons, it becomes positively charged. Where do the electrons released go? The released electrons forms a sea of electrons. And the electrons in the sea of electrons do not belong to individual atoms. You cannot notice that this electron is coming from this atom, this fixed atom. No, they just form a sea of electrons. And these electrons are delocalized electrons. Delocalized here means they are able to move. So as the delocalized electrons move around the metallic structure, since electrons are negatively charged, while the metal fixed atom now they are positively charged, they get attracted to the positively charged fixed metal atoms and form electrostatic force of attraction. So we are saying as the delocalized electrons, from the sea of electrons, delocalized simply means they are able to move. So as the delocalized electrons, they are able to move within the structure, they get attracted to the positive charged fixed metal atoms. Why? They are oppositely charged. Doing so, they form electrostatic force of attraction and form a metallic bond. This is how a metallic bond. So in short, we can say the fixed metal atoms in a metallic structure release its valence electron and become positively charged. The released electrons forms a sea of electrons, and the electrons does not belong to individual atom. As the delocalized electrons move around the metallic structure, it gets attracted to the positively charged fixed metal atoms and form electrostatic force of attraction. That's how it is formed. Now we have some past session. Past session means quick exercise that we're supposed to go through. The first one, the electron configuration of aluminium and copper as indicated below. We have 2,8,3. Then copper we have 2,8,18, 1. Which of the two metals is a better electricity and heat conductor? So looking at now the number of valence electrons which they are going to contribute in their structure, we should be able to tell that this one will be a good electric conductor. And explain your answer. Describe how ammonia is formed. So using the knowledge of covalent bonding, we can explain how ammonia is formed. State 3 ways in which atoms attain stability. That one we can also answer it. So for any questions, we have our WhatsApp number here. We can also visit this one for more. For resources, we can get the information from Excel and Succeed Junior Chemistry Book 2, Achievers in Chemistry Book 2, Django Chemistry Book 2, Target Chemistry Book 2. And for photos, images that we have here, we can also get them from the links which have been aligned here. But this lesson so far, we have covered the success criteria, 2 success criteria, that is should be able to explain or describe covalent bond, as well as metallic bond. So we have said we have several types of covalent bond. We have single covalent bond, we have double covalent bond, we have triple covalent bond. We also have other covalent bond depending on the number of electrons they are sharing. And we've said covalent bond, covalent means sharing, so it means in that covalent bond there are no ions which are going to be formed because each atom attracts to the shared electrons itself, so they contribute the shared electrons for them to be stable. And we've also looked at metallic bonding. That type of bond only exists in metals. And we've said that the metals, since they are fixed atoms, they release their valence electrons. As they release their valence electrons, the electrons forms a sea of electrons, and those electrons does not belong to a single atom. As they move, they get attracted and form electrostatic force of attraction, which lead to formation of metallic bond. Till next time, that is the end of our presentation.